Okay, cool. So I'm Carter Feldman. I'm the CEO and founder of QED, and today we're going to be talking about dynamic NFTs on QED. So QED offers a great solution for fast, scalable, on-chain dynamic NFTs. So if we look at the problems that I guess most dynamic NFTs or NFTs in general when it comes to gaming are facing, we have a lot of unhappy gamers that are upset about studios just using NFTs essentially as a useless way of earning extra revenue without providing additional value to players. So, and then additionally for Web3 games, we see a lot of studios that are, I guess, pumping out some games which perhaps aren't very fun or are kind of sort of thinly veiled dApps themselves. And in general, very few Web3 games are able to organically grow their users without some kind of bribery towards the users themselves. So there's a lot of sort of play to earn or bribe to play type of games. And then also existing NFT items generally are static, and when they're not static, the metadata isn't stored on chain. So in those cases, it's of course hoped that the metadata itself doesn't affect the value of the NFTs. Otherwise, someone could just edit the centralized server, which is storing the metadata, and your NFT could go from a level 1000 sword to a level 1 sword. So for people that are investing in NFTs and want to use them in practical ways, right now blockchain is really lacking a coherent solution. And then on the publisher side, integrating with blockchains is not super trivial, although it may be easy to integrate some Ethereum SDK into Unity and get some very basic functionality. In order to deeply integrate it with your game's logic, it usually involves disrupting the entire game's flow, all of the existing game mechanics that game developers are used to using to make their games as fun as possible. And we just end up with unhappy players and publishers, which is a zero-win situation. So so QED is a layer 2. We're horizontally scalable. We have local proving, and we'll kind of go into that in a little bit. But from the gaming side, we offer a lot of really great options that allow publishers to provide the same value, the same sort of gameplay experiences that you would see in a Web 2 world, but with Web 3 security and with ownership of the in-game assets actually belonging to the users in their hands. So we have fully on-chain stateful NFTs that you can locally mutate or update according to state machine logic that's defined by the NFT publisher. We have even real-time updatable NFTs, let's say you're in a PvP battle, and every time you're struck by a given player's sword, or you have some armor that upgrades as you're fighting along, we can update those things in real time and see the changes even on block explorers like OpenSea. So in addition, we have zero gas fee updates. So essentially what this amounts to is we use ZK proofs to prove each transaction in a QED contract. And essentially the way that it works is each transaction proof that you create also recursively verifies the previous transaction proof. So when you actually go to submit your changes to the network, you only need to submit the very last proof in your chain, because the last proof proves the proof before it, and so on and so forth inductively. So the last proof is equivalent, or verifying the last proof is equivalent to verifying all of the proofs in the chain. So this means that while we still do have gas fees as a network, you can submit a single transaction with no gas fee, or you can submit as many transactions as you like with a single proof with a fixed gas fee. So whether or not the game wants to sort of take that gas fee burden onto themselves, they can, and it's not very burdensome because submission of a proof costs around 1/10 of a US cent currently, and you can have as many dynamic NFT updates as you like. We'll also get into delegated proving in a little bit, which is a solution where we can get instant finality for games without having to have the user consistently pay for lots of individual or pay for individual transactions that we're submitting to chain. And then for game developers, you don't have to modify your gameplay to suit blockchain's tech limitations. So I guess one of the sort of big deal breakers is for all of us that are familiar with the game industry, that there are very well-crafted flows that target users towards certain behaviors like purchasing in-game content and so on and so forth. And there are people whose jobs are just designing that user experience. right? You're trying to maximize revenue for your game, and these are like kind of the cornerstone or the most important parts of an individual game's development towards the revenue of the publisher. As soon as we add blockchain to that flow, we've seen a lot of conversion breaking logic get added into that pie. And as soon as you put a barrier in front of the game publisher and their user's wallet, this usually leads to lower revenues for the game. So, but with QED, we have a very easy to use SDK, and we have all of these sort of mechanisms built in. For instance, the recursive transaction proofs, which basically let the game decide when it's appropriate to request the user to provide a signature and to either pay for gas themselves or pay on behalf of the game. So the games can design these user journeys like they're used to doing, where when you have a potentially conversion-breaking event, you can very carefully architect when that event is going to occur and thus not lose your paying users. So yeah, we have also compatibility with Unreal and Unity inventory systems out of the box, a lot of popular ones, as well as some character controllers for individual weapons and NFT items. So yeah, studios can focus on making great games instead of like working or understanding technology, blockchain technology rather. But yeah, so we can see some demos of our dynamic NFTs. So these are actually we're submitting per event. So this just shows like how fast our block finality basically is, or how fast our block times are. But yeah, so I'm locally proving all of the updates that we see here every time I do a hit. And we can see the update live on OpenSea. So over here, we have a web verifier for block proofs on QED. And it's hosted on IPFS, so it's like an immutable HTML file, one single file with all the JavaScript inside. So we can't change the logic, and no centralized backend or person can change the logic. And what it's doing is it's reading a stream of live updates that's coming from chain. And specifically, that stream is a bunch of Merkle proofs. And then every time a block, is proved, we also verify the block in the browser. So we have our own like WASM verifier for our proof system. And the main point is that whatever number you see on the page is guaranteed to be the actual state of the NFT. So if that visual display of the NFT's current metadata affects the value of the NFT, you can be sure as a buyer later that whatever NFT you're purchasing is exactly as pictured, right? So we can all imagine, like, let's say there's a potion that you can drink 100 times, right? And it's like a super, XP or XP boost potion, or a super, juggernaut potion, right? And someone has used it a few times and then doesn't need it anymore and has listed it on OpenSea. It would be a tragedy if someone then went along and purchased that item only to find out that, maybe the game backend got hacked, or someone manipulated the data, and now this like potion only has like one use left, right? So here we can be absolutely certain as a buyer that you sort of you get what you see, and you see what you get. So yeah. So we also have a full rigging system, because I guess one of the other perhaps less considered but very important parts of this sort of like smart asset revolution is that you should be able to own the NFT assets that you purchase. And what does it mean to own something? It usually means that you can use it however you want, and also whenever or wherever you want. So we're very, very bullish and working very hard on getting games to start allowing users to use assets between games, at least within their own ecosystems. So while many game studios obviously don't want to like cannibalize their own revenue or allow competitor publishers' items into their games, we have had quite a bit of supportive feedback for, let's say, within a single game publisher's own ecosystem, the allowance for sharing of items between games. And one way that we do that is by providing open asset standards for all the different types of NFTs. So you can imagine that, like, let's say you have a sword NFT, right? It's just a 3D model. But when you actually want to use this sword in a game, Unity or Unreal, specifically your character controller, needs to know, how do I equip this sword, right? What is the hitbox for the blade of the sword? And so on and so forth. So we have a bunch of AI-assisted tools that help you do that rigging. So I don't know if you guys are familiar with like Mixamo or some of those other tools provided by Adobe that help for like rigging characters. You can kind of see this as us, in addition to providing the data layer or the trustless compute layer, we're also providing the tools that make NFTs cross-compatible between games, much similar to Mixamo. So the main point here is that as an NFT owner, we want to make you actually be able to feel that ownership and be able to, let's say one game shuts down today. Ideally in the future, if the publisher is publishing additional games, or if you're in a metaverse that has configured their game to just allow any 3D models within certain restrictions on like triangles, of course, but you should be able to use those assets, in the future. So your ownership of that asset should not be dependent on the game publisher themselves. And this also usually makes people, I guess, more willing to purchase items that are perhaps higher ticket value, just because you know that you can use it no matter what. So, just to go into QED a little bit. So we allow you to write smart contracts in JavaScript and Python. So as a studio, you also don't need to like hire Solidity programmers just to write your dynamic NFTs like state machine logic. You could write in JavaScript or Python. So we also have a horizontally scalable state model. This is one of the great advantages of DK, of course, which is that we can split up the work or a bunch of different work and then verify that work being correct without having to repeat doing the work itself. Horizontal scalability helps when you have 30,000 or more concurrent players online in a game. We definitely want to make sure that we're not causing any downtime to any of our partners. And then, we're retaining the full Web3 security that we come to expect. So right now we offer 4 key SDKs. So currently we haven't launched like our public testnet, but for our private testnet, we're targeting Unity, Unreal, O3D, and Godot. These are by far the most popular game engines. So by integrating QED, you don't just get access to QED's own, I guess, smart contracts or NFT network. We also have bridges with many of the major L1 chains, trustless bridges. And you can also import in assets from those chains using our SDK. So we're really trying to make it just as easy as possible, no matter what your use case is as a game developer, to be able to integrate QED. Do we not have much time? Good on time? Okay, cool. Just to sort of show some of the developer tooling we've built. So here's like our web IDE. You can visually debug smart contracts and log and everything that a Web 2 developer would expect out of an IDE. We have worked very, very hard to support. This is in contrast to some of the tooling that we've seen with Solidity. Not so great. So the main thing is like, as a developer, you should be able to prototype and just bang out dynamic NFTs in JavaScript. So just to go into a little bit of how like the user experience flow goes. So once you've built your QED smart contract, we compile each function to an individual zero-knowledge circuit. And then your users will recursively prove each transaction they make locally. As we see, like they can either submit it when they're done to the decentralized proving network, or we also have a delegated submitter system, which we'll go into in a second. But the main thing is that, as I mentioned, one proof can prove unlimited dynamic NFT updates. So now we can talk about instant finality. So we have this concept on QED called delegated submission. And essentially what it is you say, let's say I'm about to play, Call of Duty as a user, right? And I want to use some of my NFT guns. I will say for the next hour, any transaction that I submit on behalf of my account needs to be signed by me and by Activision's game server, right? So that means that for that period of time, I can't submit transactions to chain without Activision's signature. Now, they still need my signature, so Activision can't just like steal all my stuff, right? I still have to agree. But it gives us this instant finality, which essentially works by, after we've delegated some game as our submitter, I can prove my dynamic NFT updates locally, sign them, submit them to the game publisher, and then the game publisher doesn't need to immediately submit them to chain and pay a gas fee, right? They can still be confident that the state of the NFT is, as I have now proved it to be, because they can submit that last proof at any time they like. So imagine I'm like, I don't know, using some weapons and so on and so forth, and this is affecting the game state, and we need like very, very fast finality. Maybe it's like an FPS, like Call of Duty, as I mentioned, where we need like sub-millisecond verifications of in-game actions. We can do that without having to wait for an entire block to be proved. Because as a user, during that hour period, I can't submit any transactions which will conflict with the proof that I've sent. And Activision, of course, by just signing the proof they've received from the user, they can submit it to chain and finalize all of the changes that the user has made. So yeah, as long as Activision submits that latest proof or the end proof before the delegated submitter sort of time period ends, then you get finality on chain and everything updates on OpenSea and everyone's happy. So this, of course, is awesome because we only have to pay gas one time for hours, or 1 hour, if not hours of play. And again, this gas fee is like, a tenth of a cent at most. So like, it's relatively comparable to some of the bandwidth costs that will be involved with running a multiplayer game. So it's not really like a significant financial burden for the publisher, which we do see with existing, on-chain integrations for a lot of games. So yeah. But yeah, some of our key partners and clients, obviously we're very excited about onboarding more, and we have many other business development partners in our pipeline. Yeah, I'm curious, does anyone have any questions or anything that I can help with? Yeah, thank you.